In this lesson, we're continuing using u substitution to find our integrals, but now with exponential and log function. So here, for example, we have 2 times e, but not just e to the x. Notice how it's e to the 2x. So again, this is an example of u substitution because u in this case is going to equal 2x. And just like before, we're going to find the derivative. So the derivative of 2x is 2 dx. Do we have 2 dx? Yes. So that means we can do directly substitution with everything here. So this is e to the u du. Then just like if we had e to the x, it's still all the same, right? U is a variable. So the integral of e to the u is e to the u plus c. So again, that means here our integral is e to the 2x plus c. So again, still using our u substitution here in this case, because notice it's not just e to the x, right? We have like a function inside. So then here, is this our u substitution? Absolutely. What is u in this case? 3x plus 1. Then again, we find the derivative, which is 3 dx. Do we have 3 dx? Nope. So we need to solve for dx. If it's being multiplied by 3, then divide by 3. So notice dx is 1/3 times du. So 1/3 times. Then substitute, so e to the u du. Then again, we find our integral. E to the u is still e to the u. So 1/3 times e to the u plus c. So again, our integral here is 1/3 times e to the 3x plus 1, because that was our u expression, plus c. So here we'll do another one. Oops, sorry. All right. So in this case, what is u? 3x squared. So again, finding the derivative. Derivative here is 6x dx. Now, do we have 6x dx? No, we have 2x dx. So I'll still go ahead and solve for dx and divide by 6x because that's what's being multiplied here. So this is 1/6x times du. So if you think about this, right, this is 2x times 1/6x, or 2x divided by 6x here, then times e to the u du. Now, let's simplify this because x cancels out because that's just 1. Then 2/6 is 1/3. So this is finding the integral of 1/3 times e to the u du. So notice it's just simplifying. And then here we go. Integral again of e to the u is e to the u. So 1/3 times e to the u plus c. So after substitution, 1/3 times e to the 3x squared power plus c. So go ahead and pause the video and try this one on your own. And here we go. You should have identified u is 4x minus 3. The derivative is 4 dx, but you should have noticed you can't just do direct substitution. You had to solve for dx by dividing by 4. So this is 1/4 times du. So 1/4 times e to the u du. Then again, this is 1/4 times e to the u plus c, which means our integral here is 1/4 e to the 4x minus 3 plus c. So the last type of examples are working with natural log. So here for this first one, Well, what is u in this case? The natural log of x. So u is the natural log of x. Here we go. So now the derivative of natural log of x is 1 over x dx. Now, do we have 1 over x? Yes, we do. We have 1 over x dx. So this is a direct substitution. Here we've got u to the 5th du. Now just apply your power rule. This becomes u to the 6th divided by 6 plus c. So rewriting with our substitution, our integral here is 1/6 times the natural log of x to the 6th power plus c. Now, here with this example, this is actually a u substitution. Now, we're used to going, but Ms. Reiner, wouldn't we simplify this? Well, that's if we had, let's say, like 3x plus 1 divided by 3, because all we're doing here is taking these values and dividing by just 3. Like this would be x plus 1/3. However, we are now taking 3 and dividing it by the expression 3x plus 1. So that's why this is not a simplifying problem. This is now u substitution. In this case, we need this to be like one expression, right? So this is u is equal to 3x plus 1. Now we find the derivative. Derivative is 3 dx. Do we have 3 dx? Yes, 3 dx. Now, be careful, right? Because this is not just u, right? dx or du. Because notice how 3x plus 1 is in the denominator. So this is 1 because we replaced 3 here, right? Remember that? So 1 over u because it's in the denominator here, du. Now remember, what is the integral of 1 over u? Like 1 over x. Natural log, but remember natural log of the absolute value of u plus c. So here, after substituting back, this is the natural log of the absolute value of 3x plus 1 plus c. We're going to do another one. Let's do this one here. So again, what is u in this case? X squared plus 1. Now let's find the derivative. The derivative here is 2x dx. Again, do we have 2x dx? No, we have 6x dx. Now, I'll still go through and do like what a lot of people do, which is go ahead and solve for dx. Divide by 2x. So notice this 6x here, right? We are taking 6x and dividing by 2x. This is times 1 over u, because again, here 6x times 1, there's our 6x, and x squared plus 1 is in the denominator, 1 over u, du. So now notice when you simplify, again, 6 divided by 2 is 3. So this is 3 times 1 over u, du. Now we can find the integral, which here in this case is 3 times the natural log of the absolute value of u plus c. Then substitute back in. Integral is 3 times the natural log of the absolute value of x squared plus 1 plus c. So here, try this one, pause the video. Try this one on your own. And here we go. U is 7x minus 5. The derivative of u is 7 dx. Can we directly substitute? Yes, because I've got 7 dx here. So this means substituting, you should have 1 over u, because again, 7 dx is being substituted by du. Now, integral. Integral is the natural log of the absolute value of u plus c. So then after substituting, The integral is natural log of the absolute value of 7x minus 5 plus c.